Okay. Okay. So I want to take you back to pre-networks, mainframes, protocols, and client servers. I want to talk about some of those things. Some of you will know all about this. Some of you will not know anything about this. And then I want to zoom ahead to where we are in 2020 and talk a little bit about the ubiquity of computing and mobility and what it means to have smart clients, right? And that's by way of introducing the distinction between networks, the internet, and the World Wide Web. And that's important because the first set of media that we're going to look at, apart from sort of tabular data, is text, right? You know, what happened to text and textual experiences over the course of the life of the internet. And then we're going to look at a case study after the break of what happens when all of the information, mostly textual information, but not exclusively, can be accessed quickly and indisputably in some ways over the web. Okay? So trivia for today, I want to know if anybody remembers the first quasi-commercial web browser. If you don't remember it, do you know what it was?
Netscape.
Netscape is not the first. But good for you for reaching back that far. Any other guesses?
Internet Explorer, was it?
It was not an Internet Explorer. In fact, Internet Explorer was created from a browser called Spyglass.
Would this have been something in DOS, or would this be more Windows 95?
It was, okay, that's a really good question. This was more Windows 3.1. And in fact, not Windows at all. It was more Sun workstations, Unix machines.
Here's a question. Are we allowed to use a search engine to find the response?
Absolutely.
Okay.
But I'm going to give you a time limit on this. You have 5 seconds starting now. 3, 2.
World Wide Web.
What's that?
World Wide Web.
The World Wide Web. Very good. No, it's this one, guys. I want to show this to you. It's Mosaic.
Okay.
Right? Look at that. You see that?
Jesus.
Isn't that amazing?
Wow.
That's like a year or two after the web was actually invented, right? And it's one of the original web browsers. It's one of the original ones that was used by the National Center for Supercomputing Applications.
But this was
University
used
of
by
Illinois.
the Army, right?
What's that?
This was used by the Army.
It was used by the Army. It was used by people in universities. It was used by all kinds of people. This is the 90s.
My grandmother still uses it.
Oh, she doesn't. Come on.
In 1991 was like the birth of the information age, I remember. Or
No.
something.
No.
The 1990s.
No, not really. In fact, let's talk about that, Bob. It's not the birth of the information age. Birth of the information age. Oh, I've got trivia for you too. But you can see this now. How many Alexa-enabled devices has Amazon sold since January in 2019? And the answer is 100 billion.
Wow.
Right? No, 100 million. I can't read. 100 million. And how many Google Assistants are installed by the end of January 19? That's 1 billion, right? So that's already way out of date. That's a year out of date. But that's how many voice-enabled devices there are. Now we're going to go back to the beginning of the information age, which is not the 1990s, it's the 1960s.
Wow.
The original big push for computers, believe it or not, comes right out of that era that I talked about a couple weeks ago with IBM selling tabulating machines. These are mechanical and analog tabulating machines that literally use punch cards to tally up information punched on the card, right? And in the 1960s, the son of the original founder of IBM, Thomas Watson Jr., basically bet the entire company on producing the IBM System 360, which you see in the left-hand side here, right? That was the first sort of commercially available computer to people. Before that, the worldwide market for computers, according to IBM, before they did this, the worldwide market for electronic brains, electronic computers, was 5. They figured they could sell 5, right? 1 to each of the nuclear powers in the world at the time, because you needed a computer to be able to build, you know, atomic weapons or reactors. But in the 60s, the CEO and, like I said, the new CEO of IBM bet the entire company. He invested $1 billion in the 1960s, early 60s, which was just a ton of money. And I feel like I should do a Dr. Evil here with, you know, $1 billion. We're used to talking about trillions, but at the time that was just in real terms today, that would be an astronomical amount of money on this computer. And it was snapped up by many, many companies very, very quickly and changed the face of American business in the 1960s, okay? And it's important to understand just how revolutionary it was. I don't know whether you guys have seen 2001: A Space Odyssey, which was filmed in 1969 by Stanley Kubrick, and it has the evil computer in it named HAL, right? And at the time, people said, "Oh, HAL, that's 1 letter away from IBM." You know, so they have this murderous computer on board in space in the future, and it's really IBM, but it's HAL instead of IBM, right?
Yep.
And Kubrick said, "No, that's just a coincidence. That didn't actually happen. I didn't mean that at all." And yet, when they were preparing 2001 for high definition transfers, for Blu-rays and things like that, people looked at the computers in 2001 and they all said IBM on them. They didn't even say HAL. They all said IBM. So IBM was synonymous with computers in the 1960s. I don't know whether you saw the movie Hidden Figures, which is about the contribution made by women and women of color to the American space race and putting people on the moon in the 1960s. There's a great scene where somebody, where they have actually ordered an IBM System 360 to help them do some calculations, because most of the calculations done back then were done with slide rules. Even calculators were very, very rare and very, very expensive. And it's hard to wrap your brain around that, but it's true. And they can't get the computer in the door, right? It's too big for their doors. So they actually have to knock holes in the wall through the door frame to actually get the 360 inside NASA, right? Which is pretty funny. But that's what computers were. And they were mainframes, right? Which means they were a centralized computer connected to a bunch of what? Monitors and keyboards. And that's what I'm showing in the middle. That person looks like they're working on a computer, but they're not. They're working on a dumb terminal, right? There is no processor in that monitor other than to display things. There is no central processing unit in that keyboard other than to connect it to the monitor and to the thing on the left, the central mainframe, right? So you guys have no doubt heard about, the mainframe is acting up and those kinds of things. But these were huge, huge devices used for data collection and the killer app, of course, for business, databases and tabular data. Exactly what I've been trying to tell you guys about, right? So look at this. Let's see some data. Data processing. Look at that. You see this? See that beautiful data processing room? The woman there entering data. And do you see the tape reels in the background? There's no hard drives or diskettes or anything like that. This whole thing is the computer system, right?
Wow.
Yeah, and that would be advanced because you know what these also ran on, right? Punch cards, right? But the 360 was very, very advanced, right? So you could actually have it run problems, store those problems on tape, and then you actually get some feedback. Now, it's interesting to look at all these pictures. This is a very, very important operation she's doing. She's probably doing data entry, right? That's a data entry clerk job, right? She's at a keyboard. It doesn't even have a monitor, right? And it's connecting to all these computers. These computers are also liquid cooled, folks. You have to run your plumbing through these computers. So the floor is actually raised and it has pipes going through it just to keep the heat down, right? And certain buildings I've been in from IBM were actually designed so that they could be heated by the excess heat of these computers.
Wow.
Yeah, it's kind of unbelievable. And as late as the 1990s, you could still walk into universities and see these types of computers. I know that sounds absurd, but it's absolutely true. They ruled the day for many, many, many years. Let me show you this.
They're from 1965, right, Professor?
Yeah, they're in the 60s. Yeah, the System 360 went on through the 60s, but yeah, about there's 1964.
Okay.
Right? I wanted to show you Sabre. Do you have a picture of the Sabre system? Nah.
Yeah.
But the
I think
Sabre.
that's,
Sorry, go ahead.
yeah, that's what they use for the Apollo landing, I think, or.
Well, yeah, the System 360 is the one that helped them get to the moon. I mean, there's a picture from 1964. That is not the Apollo. That's probably Gemini. Right?
5 years later, 1969.
Exactly, yes. But this is much more important because what do you think this is? What do you think, guys?
Stocks trading?
Not stocks trading. This is something you so take for granted it's not even fun. What do you think they're doing?
No idea.
Looks like they're betting maybe, right?
Yeah.
Horse races.
Nope. They are getting tickets for airplanes.
Wow.
This is the first giant database of online ticket information done on the IBM System 360 in the 1960s by American Airlines. And it's called the Sabre system, S-A-B-R-E, right? So all of that stuff we were talking about with Excel, that would have been a dream to these people, a dream to those corporations. The reason that Excel and before it Lotus 1-2-3 was such a huge deal is because being able to work with tabular data like that and then relational databases lets you run business much, much more effectively and efficiently. Everything from payroll to customer mailing lists to ticketing to indeed the military industrial complex. So, I mean, IBM had some pretty advanced stuff for actually detecting incoming Russian jets and those kinds of things. And I will put up some links for you guys to look at if you really want to see that. It's pretty fascinating. But this is really, really important. I mean, this was a novelty in the 1960s. But now we all take for granted that we can book things online and that things will be taken care of, right? Absolutely no problem. And there it is. There's the Sabre reservation system, right? Well, it's on Pinterest, so this isn't going to show me anything. But there it is. It's the same thing, right? You can see they have these sort of marriage of business machines because IBM had typewriting business and a collating business and the new System 360, which brought everything together computationally. Now, I got to tell you, I've got a Fitbit on my wrist that probably has more processing power than the entire room we're looking at in this little picture. Okay, we're not talking about a ton of processing power, but we are talking about it being accessible and relatively inexpensive. I got to put a quote on that relatively, because again, just so you guys understand how important this was, by 1987, so 20 years after this, a full 25% of the fourth quarter gross domestic product of the United States in 1987. Fourth quarter gross domestic product, 20% of it was made up by IBM mainframe sales. Okay, I want to let that sink in for a second, right? One product makes up 20% of US GDP for a full quarter of the year, right? That is unbelievable. At the time, IBM was also the second biggest publisher in the world because they were at the crux of this revolution. The largest publisher in the world, by the way, is still the US government, just so you know. But this is absolutely revolutionary, and this is where that tabular data becomes database data, becomes the modern world. Because there's something else that IBM invented in the 1960s, and it has to do with the fact that this is IBM's system, right? Let's look at some other systems, right? There's a Control Data Corporation 6600, right? And it performs up to 3 million instructions per second. Now, I gotta look at it. 3 million instructions per second, right? Now, you know that the processor inside the cheapest Macintosh performs billions of instructions per second, right? Just so you know. But look, this is 1968. Oh, look, there's a Digital Equipment Corporation, PDP-8. I know you guys don't care about this, but did you see that did you, oh, darn it. Oh, good. Did you see that it was inside her car?
Wow.
Isn't that awesome? Do you see how small that is compared to a room? Right? And this was used at the Canadian Chalk River Nuclear Lab. That's where for years, until just very recently actually, they generated radioactive materials for medicine and all kinds of places, right? And look, they developed a small general purpose computer and programmed to do the job. It's the PDP-8, and it sold for only $18,000, 1/5 the price of a small 360. So that IBM 360 that I said was relatively affordable, hundreds of thousands of dollars. And by the time it got to GM or big corporations of the time, it would be millions of dollars, if not tens of millions of dollars.
Wow.
So here's another thing, though, that you guys take for granted. Do you think that an IBM computer could talk to that Digital Equipment Corporation PDP-8, or this thing over here for Computer Data Corporation, or the CDC 600? Any guesses?
Wouldn't they have to be the same machine back then?
They would have to be the same company at least. Because, and this is where this gets incredibly prosaic, and right back to what we were talking about before, the PDP-8 text files, right? Now, I want you to think about this. The text files on a PDP-8 were not formatted the same way that the Control Data Corporation text files were formatted, which were not formatted the same way as the IBM System 360. So if you had any one of these weird computers, and I mean, look at them all. Look, there's a Minuteman guidance computer, right? There's a Link computer from MIT. They did not talk to each other. They didn't. Okay? Even though IBM was really dominating the computing world, as it says. By the mid-1960s, nearly half of all computers in the world were IBM 1401s. And that wasn't even the best one. Okay? So you have a problem, right? You have these systems, okay? But they can't talk to each other. You literally can't send a text file from your IBM computer to another computer. And this bothered a certain kind of organization. You guys know what it was?
The Army?
The Army, the military, right? And that's what you're seeing on the right-hand side here. I'm going to try and move this little zoom blob. On the right-hand side, you are looking at the predecessor of the internet,
Wow.
okay, called ARPANET. It started in the 1960s when IBM invented this thing called TCP/IP. Okay, do you see that? That stands for Transmission Control Protocol / Internet Protocol. The name we call the Internet comes from that TCP/IP protocol invented in the 1960s.
Cold War.
Cold War. So the first thing that the ARPANET did, and that's what this was called, right? And that stands for Advanced Research Products Army, okay? The first thing they did was start to hook up different computers in different places all over the United States. So you can see in 1969, there was a connection, and it's hard to see on this small thing, so I'll get you a bigger one. There was a connection between Utah, Stanford, UCLA, and one more in California. And that would have been a mix of IBM mainframes and DEC PDP mainframes. By 1970, look, they had put wires down to connect the East Coast. And that would have been places like Harvard, like Research Triangle Park in Raleigh, and of course, not mentioned probably, all of the intelligence agencies on the East Coast, right around that area of the country, right around Chesapeake, Virginia, Maryland, North Carolina, and of course, Washington's right there too, right? So does everybody see that? 1969, it's kind of an experimental thing. There's some universities, there's some Army outposts. 1970, it's a cross-country network. 1972, they now add all of the important places, all of the important universities in the East Coast, right? And all of the important universities on the West Coast. And by 1977, it's a huge network of various computers who can now talk to each other.
Wow.
With text files. They can talk to each other with text files, even if they all format them differently. Now, I am really showing my age here, folks. By the time personal computers come around in the 1980s, if you have an IBM PC and an Atari ST and a Macintosh, you still can't take a hard disk, you still can't take a diskette from one of those computers, put it in the other one, and have it read the file. In fact, even if you can exchange the files on the physical media, because it was all physical, not networks, right? It's still, a WordPerfect file on Windows would not read a WordPerfect file from Mac, and vice versa. You couldn't do it. You literally couldn't share them. So the legacy of this sort of patented nature of the way people implemented this technology lived on for decades. But the Army couldn't have that. The Navy couldn't have that. The NATO couldn't have that. So this became the research network for the Army, for the military-industrial complex in the United States. Okay, so by the mid 70s, by 77, that last chart there, it doesn't show this, but there is a line, a backbone going into Canada at that point. Right? So if you were at University of Waterloo in the early 80s, when Waterloo was young, and you were in sciences, you could talk to scientists in Harvard using the internet. Okay?
Wow.
And you know how you do that? Anybody know what the killer app is at this point?
Email?
Email. That's right. Email is the thing that made this work. There's no web. There's no browsing, right, yet. It's just the internet, okay? And the internet is just the network of different types of computers. And in fact, the interface for this would have looked very much, very, very much like this. I'm going to show you. If I can get to it, applications. The history of computing is in your computers. It truly is. Do I want the console? No, I want terminal. There we go. This is what your interface would have looked like, folks. There it is. This is actually how your Mac runs. It runs on Unix, not on Unix, on POSIX. This is a flavor of Unix. This still has commands in it from the 1960s. And this is how your Mac does stuff. All the pretty things that you work with on top of it, runs through this. So if I want to see the contents of my Jamie folder, right, I have to give it this bizarre 1960s command, ls -r. And look, it tells me. Isn't that great? If I want to change directory and go into where? Desktop, because it's just a directory. I can go cd desktop, and now I see how it says I'm now in the desktop. And if I want to see what's on my desktop, I go ls -r, and it'll list what's on the desktop. Whoop! It would like to access them.
Wow.
Okay, so this is what the computer looks like back then, right?
Wait a minute, Jamie. Do you mind scrolling up on your bash for a second?
Yep.
Doom games. I didn't know you were a Doom fan.
I told you my son put that on this old Mac.
All right.
So there you go. This is not the history of early gaming. That's the original Doom. He wanted to see what it looked like, so
Yeah.
I lent him this. This is my old Mac. Yeah. Questions? Okay, so even mail is on here, right, folks? I'm not going to do it, but I'll show you the manual for it, right? If you want to send mail from your Mac, you can do it the way they did it on the internet back in the 1980s. And this is how you do it, right? You use the command mail, and then you need to have an address, a subject, right? And here's all the syntax, and you can do it from the command line, right? You don't need a mail program. You certainly don't need the web, right? This is how researchers and scientists and students use the internet before the web, before the World Wide Web, right? There was mail. There was other things. I'm going to close this. Yep, bye. What else did they have? Here's one of my favorites. ARCHIE. You guys don't remember this.
Good comment.
Yeah, it's the comic. No, this is it. This is what it looked like. This is before the web. This is not in a web browser, folks. This is actually what you would do, right? You would search for things, and it would go out, and it would execute a search across different nodes on the internet, and it would come back looking like this, right? Without the links, because there are no links. There's no links. Okay, so don't look at the links. Okay, it would find 100 hits for, say, Linux, right? And you see it says 1, 2, 3, 4 on the left. Can you guys see that? So if I want to download number 1, I would click 1 on my keyboard. There's no links and there's no mouse. Okay? It's just very straightforward. And then it would use something called FTP, which is another command, stands for File Transport Protocol, right? That's another command to get stuff from one computer to another. And in fact, I still use FTP today, right? So this is an FTP client. It connects to my website, right? You know, there's all kinds of stuff here. Let's refresh that. What the heck? And you know, this is my website, right? This is the one you guys log into. Now, it happens to be a sub-site. So if I go to public HTML here, right? And I go to jrtechcom.com. Oh, look, that's all WordPress stuff. Don't even worry about that. But there's the courses folder, and there's 2200.
Wow.
Right? So I'm using FTP. This is not a browser. I executed basically these commands, right? In this window up here, do you see it? And then it came back with a bunch of things based on how I logged in to this computer, right? And this computer is in New York somewhere. Like my server's in New York somewhere, right? And so you know, I have when you actually use a web browser, you also go here. But I'm using FTP, and this is not new technology. It's very, very old technology. You know what, though? It's really useful technology. Have you ever wondered about how you can send a file around, you know, to people? You know, if we all had FTP and everybody knew how to use FTP, including the command line FTP, then we could just send each other things immediately. You know, email basically uses a different protocol to do that. And Box or Dropbox or Google Drive or, you know, the cloud storage systems, you know, those things, they basically use this underneath the covers and they put a browser face on it. But this is the internet before the web. Email, FTP, right, file transfer protocol, and ARCHI, a whole bunch of other things that came before the web that are sort of best left forgotten. But I want you to understand that this all works on text. It works on text files. You're not exchanging pictures, okay? So the evolution of media here is that, wow, we can exchange text files, which means I can send you a message. That's huge, 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 right? Because before this, you'd have to do it by mail. And by mail, I mean like actual letters that you'd have to write and the post office would have to deliver, right? Physically,
Oh,
okay?
yeah.
Any question about that?
Well, was this during the time of dial-up internet, or?
Yeah, absolutely. So to put this in perspective, folks, Windows 95, okay? And I know you guys don't remember Windows 95.
Windows.
Windows 95, okay? Do you remember that? No, of course you don't remember it. You guys weren't born, a lot of you. But
I
this was
remember the
Windows
logo.
95. Yeah, you remember the logo. It had a lot of cool stuff in it. It had CD capability, so you could actually load stuff from a CD, from a disk. It had videos with it for the first time, right, which was pretty cool. It looked like this. So isn't that awesome? That's
Yeah.
what your computer looks like. It did not have, now it's interesting, it says the internet here. Windows 95 did not have originally what's called a TCP/IP stack, right? It came with that, and it was a big deal, the second version of Windows 95, the big one that they launched, right? But Windows 3.1, 3.11, and the ones in between, if you wanted to get on the internet, you had to buy your own software just to get networked there, okay? So mainframes and big computers had all that stuff. PCs did not.
What about the speed of data transfer?
So you would use dial-up, right?
Oh, okay, got it. It was really slow.
300 baud. Okay. So can you still use dial-up internet? Yes. And if with a phone line and the right equipment, you can likely get dial-up internet. There you go. This is really, really slow. And there it is. There's a fast modem.
Oh,
Okay. Yeah, you'd have to buy that thing. Look, it's a fax machine as well. Isn't that awesome? And the top speed of this thing, I wrap your head around this, this was fast, was 28,800 bits per second. Not megabits per second, bits per second. 28 kilobits per second.
oh, shit.
Okay? So if you were going to download a movie, right? Netflix, it would take you about, I don't know, a month
Wow.
at least. No, I seriously, if a movie is a gigabyte, I don't know, you can divide 28,000 bits, 28 kilobits into a gigabit and see how that works. It's a long, 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 long time. Okay? But that was fast. So the only thing you were uploading and downloading was
Text.
text files. This is a story of text, folks. It truly is. Okay, I know a lot of you have heard me say this already, so that's why I'm getting good responses, and I'm glad to hear it. It means you guys learned this. It is all about text files. And in fact, some of the first things on the internet, right, and not the web, but the internet, were things like this, right? Project Gutenberg. Now, this is on the web, folks, okay? but this is a library of 60,000 free ebooks. Okay? Now, you were able, believe it or not, to download these books as text, you know, if you had the right connectivity 25 years ago. Okay? And, you know, these are all open, not open source, what do I want to say? Copyright free, right? So there's lots of different bookshelves and books, but you won't find anything that has a copyright, okay? I don't know what's in the children's bookshelf. I don't know. Anybody want to search for a book?
Lord of the Rings.
No, Lord of the Rings isn't going to be there. Lord of the Rings has got a copyright. See? Sort of by
But
popularity.
you mean like a public access, like an old book sort of
Like
thing?
an older book, yeah.
Bridge to Terabithia? Bridge to Terabithia?
I don't think that's going to be there either. Let's try Sherlock Holmes.
Okay.
Reliable.
Oh, look at that. All of the adventures of Sherlock Holmes, which have been out of copyright for many, many years, right? Look, the Adventure of Sherlock Holmes. Plain text. This is what it would have looked like. Here it is. It's the Adventure of Sherlock Holmes.
Hand of the Baskervilles.
It's got all of them, right? No, not the Hound of the Baskerville. That's a separate book. This is your short stories, right? So everything from A Scandal in Bohemia down to The Adventure of Copper Beaches. Now, what do you notice about this? Other than the fact, I know I'm boring the hell out of you here. I know I am. But tell me, look at this. What does it look like?
Plain text.
It's plain text, but what does that mean?
Means I could read it on a computer back in the day.
It's true, but what else does it mean?
It's hard to read.
Well, is it hard to read?
I guess it depends. What else? What else?
Come on, it's plain text, folks. What does that mean?
The size of this file is small.
The size of the file is very small and can be compressed even smaller by putting it into a zip file, because compression does things, and we'll talk more about this, does things like get rid of the blanks and the spaces and goes, well, we don't need the blanks and spaces. Those are for people, right? So you can save a lot of room. But what else? What else do you notice here? Just quickly glancing.
Some of the characters are not displaying. I don't know if that's what you're looking for.
Some of the characters are not displaying because they are...
Trademarked.
What's that?
They're raised or trademarks.
I'm not quite sure I understand what you're saying.
There is a trademark sign there.
No, that's not a trademark.
There. TM.
Where do you see TM? I don't see TM.
Oh,
You just highlighted the word.
Yeah. Oh, that's not, yeah. But what is that supposed to be?
an apostrophe.
It's supposed to be an apostrophe, guys. Why is it showing up as a...
Did they not have
Euro.
that symbol back when that was text was written?
Special characters are not supported.
Correct. They did not have the character set. Text, plain text does not support extended characters. One of the extended characters is a curly apostrophe, as opposed to the straight one. Right? So that, I mean, what else? What else is not here?
There's no format.
No, there's no formatting really, other than
spaces and line feed, nothing else. What else?
I don't see chat.
One font.
It's one typeface. There's no graphic typefaces, no graphics at all, right? So this is just text. Now, why did people think this was cool back in the day? What can you do with this right away?
Read a book?
Well, you can read the book, which is pretty cool. I gotta say, like back in the day, if you wanted to buy The Adventure of Sherlock Holmes, it would have cost you, you know, $9.99 for a paperback. So this is free-ish. Yeah, of course, back in the day, you've also got $10,000 worth of computer equipment just to get this. But what could you do?
Well,
What could you do with this that you couldn't do before?
You can communicate with other people. You can publish your own.
You can share it.
Ah, you can share it. Okay, that's one thing. Okay, folks, now this is crucially important. I know in the world we live in, this is nothing. But in the pre-1970s world, this is amazing. You can share this. You can send this over the internet to somebody else. Right? Now, what does that mean? What are you sharing?
Information.
Yeah, but what about it?
You're sharing the text to another person that may have the capability to accept this link.
That's true. But what else? I mean, I want you to really think back here. What would I have had if I wanted to share this book with somebody before the internet, and I didn't want to give them the only physical thing? What would I have to do?
Oh,
Yep.
you'd have to make a copy. You can
I
make
have-
unlimited copies with this.
Yeah, you can make unlimited copies of this, folks.
That's what I said earlier.
Oh, I didn't hear it. Sorry, Harry. My apologies. So yes, you can make unlimited perfect copies.
Yeah.
Okay? So if I photocopy this, and I photocopy it, and photocopy it, the copies will get worse and worse and worse. But if I have a text file, I can make a gazillion copies of this, and every one is perfect.
Mm-hmm.
Right? And now I've got a network, which means I can send it anywhere who has a computer that can read this. Right? So there's two elements of digital media that are born at the beginning of the computer revolution. Right? The first one is, unlike any media before it, I can make a perfect original. It's not even a copy. A copy of a digital copy is the original. There is no difference. And that is the first time that has ever happened.
Mm-hmm.
Okay? The work to make a copy is trivial. Also, that's the other thing, right? The work to do it is it's minimal. It's a consequence of the medium, right? The second thing is I can connect this easily to many, many people, right? Without having to use any physical, or how can I put this? Without having to use any explicit physical means. I mean, there is a physical means, right? There are cables going underneath the water that connect North America with Europe that are the internet. I mean, there are cables that come into Canada that connect Canada to the rest of the world. And that's physical, but you don't see it. The user doesn't see it. What else can we say about this? There's a couple of other aspects of digital media.
I'm not sure if this applies, but can this be translated?
Not right away. It couldn't. And that's one of the reasons why those funky characters don't show up, because the character set in the beginning, when text files were sort of made for the internet, there's only 127 main characters and 127 extended characters for a total of 254 plus 2 spaces, 256. That's not very many characters, right? So that's another thing, by the way. The early internet was English. Even more so, the early internet was American English. So the standard character set was called ASCII, the American standard, ASCII. Right, exactly, computer interface set, right?
So sorry to interrupt. Quick question. So at one point in time, this technology was adopted by other countries.
Correct.
Unless in Europe, that maybe their language was not English, so they have to actually learn English to use this technology. Is that correct?
That is partly correct, Harry. It's really weird. Believe it or not, from a business perspective, not the internet now, but just from a computer perspective, where you have your own networks and stuff. Mm-hmm. Companies like Group Bull in France, and indeed IBM, had their own way of coding text such that it was multilingual. Okay, so if you were in Israel and you bought an IBM System 360, it supported Hebrew, right? That doesn't mean you could send things over the internet in Hebrew, but you could run your company in Hebrew, right? It's hard for us to understand, like it's hard for us to think about right now, but this wasn't the only network back in the day. There were, go ahead.
If you can't send it over the internet, how are you going to run like your company in Hebrew?
Easy. You have your own network. It's just not
Cool,
the
I
internet.
get my own network.
Yeah,
Okay.
you have your own, oh, absolutely. You have your own network. That I like, this sounds insane. But IBM used to own its own phone lines, right? When I started with IBM, this is not ancient history. When I started with IBM, I could pick up the phone in my office and call anywhere in the world and not pay long distance or talk to AT&T or anything like that. IBM owned its own wires, right? We didn't use the internet network inside IBM. We used a different network entirely. You guys probably don't remember Novell networks because they're gone now. But they were the biggest provider of network technology to businesses in the world for decades. And they were not using TCP/IP or the internet. That only was for research and the Army. And then for everybody, when a certain smart guy working at CERN in Switzerland, right, the particle accelerator, put together a bunch of old technologies that we talked about a couple weeks ago and invented this thing called the World Wide Web, which makes everything a lot easier to look at. But it was still English. And to answer Harry's question in a roundabout way, the web was not multilingual until the 21st century.
Wow.
It was pretty much English. I remember a statistic, an odd one from the late 90s, probably 96 or 97, where they said 80% of all web traffic, not internet traffic, but web traffic, began and ended in California. Right? So most of it was done in English. And most of the technology was also developed in English. So it's a complex story, Harry. Basically, you're right, though. Technologists all over the world still, if they don't speak English, they read English. Because these technologies have come from the West. They've come from America,
Yeah.
particularly.
Wow.
And Canada. Archie was invented at McGill, for what it's worth.
I've heard about that, yeah, McGill.
Yeah, first search engine.
Professor,
Yes.
so like, if it was written in Arabic, like your company, it would be automatically translated, right?
No. So in the old days, Bob, you would actually have Arabic systems, right? So if you're or Hebrew or French, if you're buying a system from Group Bull, they would give you a mainframe, right, and a bunch of keyboards that were French keyboards, and IBM's system would maintain that Frenchness all through your network. So you have your own network, and it doesn't necessarily connect to anybody else's networks. But it became a big deal, right, to manage all this. So places like General Motors, they invented their own IT system so they wouldn't have to keep paying IBM bags of money to do this for them, right?
Wow.
And that company actually became EDS, which was a huge IT organization for years and years. But it's important for people to understand that even through the late 90s, when you walked into a place like IBM or Apple even, they would have an English computer. And if you wanted to do testing in French, you had to have a French computer and a Japanese computer and a Chinese computer. Like, they're all separate machines. Right? That's how it worked. And so the character sets were all different for each one of those types of computers, and indeed for each language. So earlier in my career, when I was looking at search, multilingual search for IBM, and we were trying to do things on the internet, it was impossible. But we could do we could do things locally on people's machines. There were PCs that were Japanese. There were PCs that were French, PCs that were German. We could do that. And then along came something called Unicode, right? And Unicode is what makes the world go round, right? Unicode is this information technology that actually lets devices represent hundreds of thousands of characters in different languages, in different scripts. See, so there's Unicode 1638. I don't even know what that is, right? There's all kinds of languages, you know, and all of the modern devices these days support Unicode. Okay, and that's why the web is the World Wide Web now. You see how deep we can get into this? It sounds ridiculous, but none of this is magic, right? And it started, it started with basic American 256 characters, right? And then it ends up with, emojis.
Sorry, quick question. So, because they started with 250 characters, was that a fail for Americans with the fact that they put that limit, or simply they didn't think about they needed more?
I mean, it wasn't a fail. Remember, the internet was the ARPANET, right? It was this. And the logical ARPANET in 1977 does not extend to Europe, right? So you have all these connections, and this actually shows you, I don't know whether you can see this very clearly. This is a really good map, though. You see there's Hawaii and Stanford, and that's probably a military thing there, and it shows you what machine they have there. A lot of them have DEC PDPs, PDP-10s, PDP-11s, but there will be IBM systems here and other systems. So, I mean, the fact that it's American, when all your nodes are Texas, Pentagon, right, doesn't really matter. So it's not really a fail, right? Once it became the World Wide Web, then of course you had to extend that into multinational corporation, a multinational view, and the culmination of that is, like I say, culmination of that is Unicode, right? Is this, right? So there's lots of information about Unicode if you want to see how important that was and is still, because of course new emojis come by all the time. There's still a lot of people in the world who are very, very angry about the fact that Unicode does not represent their language or doesn't represent their preference, right? See, 143,589 characters, right? And, Unicode now covers 154 modern and historical scripts, but that's not very many. The world has a lot more than 154 scripts, right? So there's all the different things that Unicode covers. This is important because, right, you can actually use these in HTML and XML. And that means that data can be stored in these languages. And because data can be stored in these languages, all kinds of other things can be communicated in these languages. Okay? Any questions about that? I know that's kind of crazy, but it's important for you guys to understand that first came text. And that these terminals, even though they have color, are not graphic. And that it's only relatively recently that a device is capable of doing Arabic, Hebrew, French, Chinese, Korean, English, French, Norwegian, without having to have a separate device.
Wow.
Yeah.
How about Farsi or Arabic?
Yeah. So Farsi is one of the ones that came on late, but Arabic and Farsi are both supported by Unicode, I'm pretty sure. Oops. Yeah, there we go. So let's have some. Yeah, so there are actual Times New Roman fonts
Wow.
or Urdu in this case, right?
Wow.
But it's all about Unicode. If Unicode supports it, then it's there. It's in your computer even. Now, you might need some extra typefaces. And I'm on a Mac here, so I'm going to try and do this. I'm more used to doing this on Windows. Give me 1 second, and I'll see if I can show you some Unicode here. Can I do that? Oh, yeah, with the font app. Right. I was going to do it from the desktop, but give me 1 second here, and I'll show you what it looks like. It will be in utilities, right? Actually, where's search? Do we see fonts?
Just search it.
Yeah, I should be able to, right? But I can't find is it just in Finder?
Yeah.
Yeah, maybe. Let's try Finder here. Okay. Default fonts list? I don't think that's it. That's in the font folder. Yeah, this is not it. There should be an app, actually. In applications, there should be a fonts application.
Yes, right there.
Did I miss it?
The
I
F,
missed it.
the letter F right there.
I'm looking at it, the letter F.
It's font book app.
Oh, there it is, Fontbook app. Thank you, man. Thank you so much. Okay, there it is. So here are the ones that are on my computer, okay? And because I have, see, it won't show some of them even, because you've got the way the system is constrained, right? But they are there. So if assuming this is an Egyptian, right, typeface, it's not showing in the preview, but it would show in InDesign, right? Or some application that has the capability of showing this, right? There's Hebrew, it's not showing it. That's really interesting. I would have, what's that?
It's anti-Semitic.
No, it's not. It's just the limitation of showing multiple byte fonts in the preview here, right, in the app. I'm pretty sure if I went to, well, let's try it. Let's try it. What the heck? I'm just going to try it.
Maybe you don't have the font because I did the same and I can see the font.
Oh, really? That's
Yeah.
I should have them though. I should have them because they should be installed with InDesign, I would think. But maybe it hasn't initialized them. Who knows? You may be right. Anyway, I'll open it up and we'll check it after. Anyway, this is a tale of text, and some of the earliest things were textual. And in fact, the way the World Wide Web works is to leverage all this text stuff, right, and turn that into something graphic. But before that happened, people did get pictures and blobs on the internet. Now, that's a technical term, blob. It stands for binary large object, and anything that is not text is technically a blob. Okay? So you know, a picture is a blob. A movie is a blob. What else?
Sorry, so you said it was binary large object bullshit?
That's right. It's binary large objects. They're
And
blobs.
what's the BS for? The last.
Oh no, that's just plural. That's all it is. There's no BS. It's binary large object. So blob,
Okay.
right? And then blobs. Okay, so a movie file is a blob, an audio file is a blob, and they all have one thing in common, and that takes us right back to this, right back to Project Gutenberg. What can I do with this other than send it around and share it that I couldn't do before?
Bohemia.
Super important. Come on, guys, you got a paperback of Sherlock Holmes versus this. What can I do with this that I can't do with that paperback very easily?
One is copy,
Yeah, one is copy, one is send, one more.
sharing.
Sharing, yeah. It's obvious, but people don't get it.
You
I
can
can-
store it digitally.
I can store it digitally, but most importantly, the thing that made us all so excited back in the day was this little thing right here, search.
Oh, yeah.
Amanda,
Oh,
I can search this,
you can
folks.
search the
If I want to see Sherlock, if I want to see how many times Sherlock is in that text, right?
Like Microsoft Word or.
No, it's not Microsoft Word. It's a text file. It's just a text file, Bob. Just text.
Okay. Yeah, I mean, you can do that in Microsoft Word. Sorry, I was thinking out loud. Yeah.
You can, but I want to show you how important this is. Okay, I'm a scholar, right? I'm a scholar, and I want to know how many times in this book, The Adventures of Sherlock Holmes, Sherlock shows up. How would I do that?
But did that function existed at that time?
Oh yeah. String match existed, exactly. Sure, absolutely. That was so cool. You could actually take this and I could say, look, it shows up 102 times. My father was a man of the cloth. He was a minister for the United Church of Canada, and he had a library, and a lot of his books were called, a lot of his books were indexes of indexes. They were concordances, right? So that he could look up different things in different books, in different versions, in different languages of the Old Testament, the New Testament, and other holy books, right? So he could actually search through them without having to search. Because I'm telling you, if you needed to find out how many times Sherlock, ended up in this book, and it's only 102, which is kind of suspect. Nevertheless, it's 102 times,
Yeah, a lot.
right? So there used to be books of books, indexes of indexes, just to help you do this.
Mhm.
And when I was a student, way back when dinosaurs roamed the earth, and the first time that the Oxford English Dictionary went online, that was amazing. Amazing that you could take what used to constitute a literal room full of books with 30 volumes and 20 supplemental volumes and search it for the first time. That was astonishing. Just astonishing. I thought that was the very coolest thing ever. And believe it or not, you could buy whole libraries of files that were on Project Gutenberg, put them on a CD, right? A CD, not a DVD. Put them in your computer and you could search across them. So if you wanted to see in the works of Aristotle how many times he mentioned rhetoric or where he did it, you could do that for the first time ever. So this whole thing about text files, revolutionary. And text files are searchable. And the web is searchable because HTML files are text. Okay? So the very thing you take most for granted, which is the way you work with the internet and the web, the way you work with finding information, the things you do with Ask Siri or Alexa, or putting it into Google, that's all based on the fact that there is a textual representation of information and it can be read. Try to search a JPEG. It doesn't work.
Quick question. In
Yeah.
regards to this part right here, it says UTF-8.
Yes.
Is this something current, or this was used at that time as well?
Believe it or not, UTF-8 is a sub-program of Unicode. So this is current.
Okay.
Yeah, it's current. But there's a problem between the way this is representing it and the way the browser's interpreting it, and that's why this is happening, right? If I actually look at the source, which I think I can do here, and I won't do this very, very often. Let's see what happens. It might be the way they actually, see, it's just a text file, c.text. It might be the actual way they represent this. Yeah, see, something has gone wrong with their representation of text. right? In the actual downloading it to a Mac, something has gone silly, and I don't know why. It's interesting.
Mhm.
Yep. Questions about that? The first question should be, but Jamie, can't you search movies? And the answer is no, you can't.
Unless they're transcribed.
Unless they're transcribed, in which case you're searching,
Text.
you're right, the text. So that's the way it works. Can you search JPEGs?
No.
No, but what about something like a reverse image search?
Yeah,
No.
so reverse image search. Okay, so now you're talking about the cutting edge of artificial intelligence.
Right. Sir, before we
Patterns.
continue, what about the name of the file?
Yep, you can. Yes, in fact, you can search the name of the file, and when we look at JPEGs and still images and those kinds of things, you'll see that there's actually a ton of text associated with most JPEGs.
Okay.
Right? And it's metadata. So it all comes back to that tabular data, all the information there. It goes back to the beginning of computers, and it's just accrued on top. Other questions? Did I lose you guys through this?
No.
Was okay?
Pretty clear, yeah.
Okay, good.
Good.
Good. Okay, let's take a break. We're going to come back. We're going to talk about the world as it is for a second, and then I want to shift gears and talk about what happens to information that is copyable, transferable, networkable, and shareable. What happens when data kind of happens and we have to talk about security.